So, hi everyone. Today we are discussing about enzymatic catalysis chapter. So, here in this chapter, here, enzymes and enzymatic catalysis. So, here generally the enzymes are made up with of proteins. Generally, enzymes are made up of with proteins. So, here generally proteins are the polymers of amino acids. Generally, these made up enzymes are made up with proteins. These proteins are polymers of amino acids. So generally, enzymes are proteins and have complex structure because there are n number of amino acids. Generally, enzymes are proteins and it consisting complex structure because there are n number of amino acids which are attached with amide bonds or peptide bonds. These amino acids are attached with amide bonds or peptide bonds. So those are nothing but proteins. So, proteins are polymers of amino acid. So all the amino acids which are bonded with amide, all the amino acids are attached with or bonded with amide, that is NH C double bond O or C double bond O NH or peptide bonds. So all the amino acids which are bonded with amides are peptides. Here amides nothing but NHC double bond O or C double bond O NH and peptide bonds. So here generally enzymes contains large number of amino acids. Enzymes are containing large number of amino acids and it containing high molecular mass. Generally these enzymes are contains high molecular mass. So here generally the enzymes acts as a biological catalyst. Enzymes are acting as a biological catalyst. That means the enzymes are acting catalyst in so many biological processes. So here which are happening in our human body. So catalyst generally the definition of catalyst is a substance or molecule or compound which alters or alternatively, that is increase or decrease the rate of reaction by involving in the reaction and does not undergo any final change. So that is called as catalyst. A substance or molecule or compound which alters, that is nothing but increases or decreases so that the rate of reaction by involving in the reaction and does not undergo final change. So that is called as catalyst. That is called as catalyst. So here the compounds with increase or decrease the rate of reaction and it does not undergo any final change. So that is called as catalyst. So here generally catalysts are different types. Catalysts are different types like metal catalyst or non-metal catalyst and gaseous catalyst and enzyme catalyst. Generally the catalysts are different types like metal catalyst, non-metal catalyst, gaseous catalyst and enzyme catalyst. So here these substances will increase the rate of reaction. So these substances will increase the rate of reaction. So majorly we use the catalyst to increase the rate of reaction. So generally the catalyst is increasing the rate of reaction. So how the catalyst increase the rate of reaction. In generally the catalyst, what catalyst do is by reducing the activation energy, the catalyst increase the rate of reaction. So here the catalyst increase the rate of reaction by decrease the activation energy. So here generally the catalyst increases the rate of reaction and by decreasing the activation energy. So here see the diagram or graph. So in y axis we are taking energy and x axis reaction coordinate. So generally here without catalyst, in this process without catalyst the activation energy is high here. So this is a without catalyst. Without catalyst the energy will be increases. So with catalyst here the energy will be decreases. This process without catalyst the activation energy is high. With catalyst the activation energy is low or decreases. So by using the catalyst the activation energy is decreases automatically here. So here using the catalyst the activation energy is decreases. So automatically the rate of reaction will be increases. And here the activation energy is differences between the threshold energy and average energy. Activation energy is differences between the threshold energy and average energy of reactants are called as activation energy. Differences between threshold energy and average energy of reactants are called as activation energy. So here EA is equal to E energy of threshold minus energy of average. So that is called as activation energy. So then next the catalyst increases, the rate of reaction is decreasing. And here similarly here also the enzyme catalysis process here also the enzyme catalysis process also enzymes are acting as a catalyst by decreasing the activation energy. So when compared with metal and non-metal catalysts, so these enzymes will be decreases with activation energy is more. So that means the decrease in activation energy is more when we use enzymes catalyst. So automatically the rate of reaction is very high. So in the case of enzyme catalyst, so generally catalysts are two types. That is one is homogeneous catalysis and second one is heterogeneous catalysis. So first one homogeneous catalysis. So here the homogeneous catalysis means both the catalyst and reactants are in same phase are called as homogeneous catalysis. Both catalyst and reactants are in same phase, that is called as homogeneous catalysis. So whether it may be gaseous phase or it may be liquid phase or it may be solid phase, both catalyst as well as reactants both are in same phase, that is called as homogeneous catalysis. For example, the catalyst and reactants are in maybe gaseous phase or it may be liquid phase or it may be solid phase. So here for example 2 moles of sulfur dioxide react with oxygen in the presence of nitric oxide and it forms SO3, sulfur trioxide. Here both reactants, here SO2 and oxygen, both are in gaseous state, and also in catalyst NO is also gaseous state. So in the reaction, NO is acting as a catalyst. So here these both are in gaseous state, and as well as NO acting as a catalyst, and this NO is acting as a catalyst. This is also gaseous state. So in this reaction, both sulfur dioxide and oxygen, both are reactants. These reactants are in gaseous state, and here NO is acting as a catalyst. This catalyst NO is also in gaseous state. So this is one of the example. It means both catalyst and reactants both are in same phase, that is called as homogeneous catalysis. So the next example, hydrolysis of sucrose. So here the sucrose formula is C12H22O11. Sucrose is in liquid state, is reacting with water molecule in the presence of H plus, and it forms glucose and fructose, C6H12O6 plus C6H12O6. So in this reaction, the above reaction of hydrolysis of sucrose. So here in this reaction, both reactant molecules are in liquid state. Both reactant molecules are in liquid state. In this reaction, H plus is acting as a catalyst. H plus is acting as a catalyst. So both are in liquid states. So this is also one of the example of homogeneous catalysis. So the next example, hydrolysis of esters. Hydrolysis of esters. So this is the ester formula, CH3 C double bond O C2H5. This ester undergoes hydrolysis in presence of H plus, and it forms acetic acids and alcohols, C2H5OH. So here in this reaction also, the reactant, both reactants are in liquid state, and here in this reaction H plus is acting as a catalyst, and these catalysts also in liquid state. So both reactant molecules and catalyst are in same phase. So and it forms, finally it forms products, that is acetic acid and alcohol. So this is also one of the example of homogeneous catalysis. So this is a homogeneous catalysis reactions. So the next, heterogeneous catalysis. So here the heterogeneous catalysis means both catalyst and reactants are in different phase, are called as heterogeneous catalysis. Both reactant molecules and catalysts are both are in different phase, that is called as heterogeneous catalysis. So for example, here Haber process. So here N2 nitrogen reacting with hydrogen in presence of iron or molybdenum, and it forms NH3. Here reactant molecules nitrogen and hydrogen both are in gaseous state, and here iron or molybdenum are in liquid state, and it forms ammonia. So in this reaction, we are preparing ammonia by using of Haber process. In this reaction, we are preparing ammonia by using of Haber process. So in this reaction, iron and molybdenum both are acting as a catalyst. Iron and molybdenum both are acting as a catalyst, and in this process both reactants nitrogen and hydrogen are in gaseous state. Both reactants that is nitrogen and hydrogen both are in gaseous state, and catalyst in solid state. Here iron and molybdenum as acting as a catalyst. This catalyst is in solid state, so automatically this is a heterogeneous catalysis because the both reactant molecules and catalyst are in different phases. So that is called as heterogeneous catalysis. So this is one of the example for heterogeneous catalysis. So the next example, hydrogenation of alkenes. Hydrogenation of alkenes. So in this reaction here CH2 double bond CH2 ethylene is in gaseous state and it reacted with hydrogen. This is also gaseous state in presence of nickel. This is in a solid state. In this reaction nickel acting as a catalyst and finally it forms product that is ethane. So in this reaction ethylene and hydrogen both are reactants. So these both are in gaseous state. So here nickel acting as a catalyst and this catalyst is in solid state. So here also both reactants in gaseous state and catalyst is in solid state. So automatically this is a heterogeneous catalysis. So this is a hydrogenation of alkenes. So the next one, contact process of reaction. So here 2 moles of sulfur dioxide reacted with oxygen in presence of vanadium pentoxide and it forms SO3. So in this reaction both SO2 and O2 both are reactants. These reactants are in gaseous state and in this reaction V2O5 vanadium pentoxide is acting as a catalyst. So this catalyst is in solid state or solid phase. So here also both reactant molecules and catalyst both are in different phases. So automatically this is also heterogeneous catalysis. This is also heterogeneous catalysis reaction. So the next enzymatic catalysis. So here the enzymatic catalysis is a heterogeneous catalysis process. Enzymatic catalysis means this is also heterogeneous catalysis process because reactants are in different phases, so that are converted into product by using enzyme catalysis. Reactants are in different phases and these are converted into products by using a enzyme catalysis. So automatically enzymatic catalysis is a heterogeneous catalysis process. So here for example sucrose, hydrolysis of sucrose. So here C12 H1 H22O11, this is a sucrose formula. The sucrose undergoes hydrolysis in presence of invertase. So here invertase is a one of the enzyme and it forms glucose as well as fructose. So this is the hydrolysis of sucrose reaction. Sucrose undergoes hydrolysis in presence of invertase and it forms glucose and fructose. So in the above reaction, invertase enzyme acts as a catalyst in this reaction. So in this reaction, invertase is a one of the enzyme. So this is acting as a catalyst. So the invertase enzyme is converting sucrose to glucose and fructose. This invertase enzyme is converting sucrose to glucose and fructose. So the next here glucose C12 H sorry glucose C6H12O6 and glucose forms ethyl alcohol in presence of zymase enzyme. So in this reaction, zymase is acting as a catalyst. So in this reaction, zymase is converting glucose to ethyl alcohol. Glucose are converted to ethyl alcohol in the presence of zymase catalyst. So this is the fermentation process. This is the fermentation process. So here the conversion of glucose to ethyl alcohol. Glucose to ethyl alcohol. So this is the preparation of alcohols. This is the preparation of alcohols. So in this reaction, zymase as a enzyme, this zymase is acting as a catalyst. So the next example, urea NH2 C double bond O NH2. This is the formula of urea. So in this reaction, urea is converted into ammonia. Urea is converted to ammonia and carbon dioxide. So here urea undergoes hydrolysis in presence of urease enzyme. So this urease enzyme is acting as a catalyst and it forms converting urea is converted to ammonia and CO2. So in this reaction, urease is an enzyme. This urease is acting as a catalyst. So these all are the examples of enzymatic catalysis. So generally most of the enzymes are having different active centers. Generally most of the enzymes are having different active centers. So these active centers are like NH2 COO minus C double bond OH, that is a carboxylic group, or SH OH O minus and NH3 plus. So these are the different types of active centers. So like this, whatever the groups which are available in amino acids are active centers on the enzyme. So through these active centers, the substrate that is nothing but reactants are bonding. So through this process, the active centers substrate that is reactants are binding, so that it binding interaction would maybe ionic bond means ionic bond. It may be ionic bond, that means the bond between enzyme and substrate. The bond between enzyme and substrate may be ionic bonds or electrostatic interaction. That may be ionic bonds or electrostatic interactions, or it may be hydrogen bond, or it may be van der Waals forces. So through this different kind of interactions, the substrate is binding at active centers of enzymes. The substrate is binding at active centers of enzymes. So we observe process. So here initially enzyme and substrate. Here initially the enzyme and substrate, these two are binded with different kind of interactions. So here the enzyme and substrate, both these are binded with different kind of interactions, so that the enzyme substrate complex is formed. Enzyme and substrate both are binded with different kind of interactions, so that interactions finally enzyme substrate is formed. So whatever the substrate is nothing but reactant which is binded to the enzyme will form a product, and then this will form. So here the enzyme and substrate both are binded with different kind of interactions, and it forms enzyme substrate complex. So whatever the substrate, that is nothing but reactant which is binded to the enzyme. Reactant is binded to the enzyme will form a product. Will form a product. So here enzyme product complex. So this enzyme here, E is a enzyme, S is a substrate, P is a product. So this enzyme substrate finally it forms a enzyme product complex, and after that the product leaves the enzyme, so that will get a free enzyme, and again this free enzyme will be further reacted with substrate, so that enzyme substrate complex will be formed. So this is the process of, enzymatic catalysis process. This is the process of enzymatic catalysis process. So in this reaction or in this process, the substrate is nothing but reactant molecules. The substrate is nothing but reactant molecules are binding with enzymes at different kind of active centers. So these active centers are in different structure. So based on the structure, the substrate will be binded to the enzymes. Based on the structure, the substrate will be binded to the enzymes. So here there are two mechanisms are there. Here two mechanisms are there to explain the enzymatic catalysis process. So here generally there are two mechanisms are there. They are to explain the enzymatic catalysis process. So the next we are discussing enzymatic catalysis mechanism. So here two mechanisms are there. One is lock and key method, and second one is induced fit method. So here first one we are discussing about lock and key method and induced fit method.